All right, so today we're going to be just starting on chapter 6. Once again, some people having a hard time with this one, but we see what we can do to be sure we're going to be okay. Okay, so we're talking about the I/O stream, and basically what we have been doing is we were reading the information from the keyboard. The user was putting the information in the keyboard, and we are displaying it to the screen. In real life, that's not what we're going to do. Most of the program we're going to be writing is going to be run in the middle of the night, and I don't want to go there and either type in the information or read the messages that's coming out. So what we're going to do is we're going to be reading from files, and we're going to be writing to files. Okay? That's what we're talking about. First we're going to talk about the streams, basic file I/O, tools for stream I/O, and character I/O. We're going to get into that. So when we're talking about the I/O, that's input output. The standard input is what? Is the keyboard. So when we're asking the user to put something into our program, usually so far we have been taking it in as what? From the keyboard. And when we are displaying something to, it's going to be automatically go to what? To the screen, right? So the typical one you are used to is keyboard and a screen. Now we're going to do the file. All we have to do, if you pay attention, and this is the only thing I have to do, if you keep that in mind, I think you're going to be fine with this class. So if I write my whole program, and I take the cin out, and I put the whatever we call it, the input stream, and then if I take the cout out, and I put the output stream in there, that's it. So we're going to be writing inside, instead of reading from the keyboard, we're going to read from the file, and instead of writing it to a screen, we're going to be writing it to a file. And that's the whole chapter. But somehow, some students don't get it. So we're going to talk a little bit about the objects, because we need that for these things. Basically, the object-oriented design or object-oriented programming is creating some classes, and from those classes we have some objects created. So those classes are going to have a template. They're going to have some blueprint of what we have, and when we create objects, all those blueprints going to go for that object. So for example, if I say car, can you go get it for me? No, because you don't know what car I'm talking about. But on the other side of it is what? You kind of have idea what the car is. It has some wheels, it has some doors, it has some wheel shield, and it's going to be basically drivable, hopefully. But then if I point it to certain car, that's going to be the instance of that car. So I'm going to have a go to the parking lot, and a blue Volvo 4-door with this license plate. Then now we have an object of that car that was a blueprint. So if I have a blueprint of a house, that's not going to give me a house. But when we're building a house, that's going to be the instantiation of the house of that blueprint. We don't need to know all the details of this. You're going to get it in the next class. We're just going to talk about it a little bit, so some of these things is going to make sense to you. So when you're talking about the input stream, is the data flows into the program. Whatever is coming into our program is called input stream. Okay. Right now, so far, we were doing it through the keyboard. Now we want to do it through the file. So any kind of an input that's coming into our program. The out stream is data flows out of the program. So we were getting something inside. Remember we talked about the IPO, input, processing, output. Input is what's coming into our program. Output is what's going out of our program. And of course processing is what the program is going to be doing. So C-in and C-out are the input and output stream that are C-in is connected to the keyboard and C-out is connected to the screen. Those are called the standard input, the standard output. Those are defined in a pound include I/O stream. Input, output stream. So why are we using the files? Sometimes we have large data. So if I want to do something with all the zip codes in the United States, I don't want my user to keep typing all the zip code every time they want to use my program. I want to save it in a file and use it. That way I don't have my user to type it in. Or sometimes I want to display things that nobody's there, so I want to write it to a file so I can come and check it in the morning. So we're going to be, files allow you to store data permanently, so we're going to have it in there. Data output to a file lasts after the program ends, so we don't have to worry about it. It's going to be there. And in real life, what's going to happen is my program is going to read from a file, is going to output a file, and another program is going to pick up my output and is going to use that as an input, and it's going to create its own processing, it's going to create its own data file. Another program is going to come pick it up, that one, and it's going to work. So I'm going to have a bunch of programs running in the middle of the night, which is the slowest time in the computer system, and they're going to be reading and writing from each other. And right now a standard error message is going to go to the screen. I'm going to capture those things and I'm going to put it in a file. Usually it's going to be a log file or some things like that. That way if something goes wrong, we know what is going on. So when we're talking about the file I/O, we're going to read from a file, taking input from a file, and the key on that one is when we open a file, we're going to start reading it. We cannot go backward. We cannot go only forward. We cannot start over again, but when I start reading the first line or first character or first variable, then I cannot go back. I just got to close it and go back again. The writing to a file, usually what's happened is when we're writing to a file, it's going to open a file. If I don't mention anything, it's going to create a new file. What does mean? It's going to delete everything in the content and it's going to start all over again every time I'm going to write the file. And we're going to talk about how we're going to append it. So we're going to create a variable. This variable is going to be connected to the stream. It must be declared before it can be used, just like any other variables that we have. We have to initialize it, meaning that it's going to be, is it going to be an input or output stream? We can, of course, change its value. So we're talking about the objects can use special functions to complete tasks. So now that I talked earlier about the blueprint, and now when we have objects, these objects can have some methods or functions inside of them that we can use. So the classes, the objects usually have some elements, some data, and also they have some methods or function. Now we can use those because we are using those classes. Once again, these are just for your information. It is not too much for this class. If you go to the 3A, you're going to spend your time, most of your time on these things. So First, we're going to be working on the input file stream. This is the one that's coming to our program. So we're going to have a pound include f stream, and the I is for input. So I'm going to declare a variable. I can call this anything I want. I can call it in file. I can call it my file. I can call it anything I want. And right now it's calling it in stream. So this in stream has been defined as input stream. And we can do the same thing for the out file. The pound include is the same for both of them. Naming using namespace standard std is the same for both of them. Now I'm going to create another variable for my off stream or f stream. The way that I am used to it, I have in file, out file, and that's the way I have it. Now the reason we talked about the class as an object is the dot operator that we have in there. That means when I define this as a class, now I have a function that I can use. Once again, the detail of this is going to come in your next class. Right now we're just using a dot operator to open a file. So I'm using the variable I created. I'm going to use a dot operator to open this file. Okay, this file, because it's using a double code, is going to be, it has to be in the same directory than my executable file. So wherever my executable file is, then this has to be in the same place. It doesn't look other places. It's looking at the current directory. Okay. So the way I'm using it. So before, you remember, you had a cin, number 1, number 2, and anything else. Now I take the cin out. I put the in stream. So that means it's going to read. We open this file. Okay, let's go back up. So we put the pound include f stream. We created a variable called in stream. That is for the input. We use that one in a stream to open a file. This is the name of the file, exactly the way it is on my computer. So I'm going to open this file. When I open this file, I'm going to read from that file. So all I need to do is write my program, take the cin out, and I'm going to replace my cins with this word, in underscore stream. This is the variable that you define. You can call it anything you want. So I'm reading from the file. I'm reading 1 number, 2 numbers, and these are integers. So all I'm doing is I'm reading 2 numbers from the file. Yes, sir. So you're reading these 2 numbers and then you store it into the stream? No. We are storing it where? In 1 number, another number. These are my variables that I'm storing. This is just a stream. It's coming through here. It's coming through here. It's going to go to this, and it's going to go to this. These are my variables that I'm storing. Doesn't matter how many numbers it has. I am reading 2 numbers. It can have 55 numbers. It can have 155 numbers. It can have 2 numbers. I'm reading the first 2. Yes. When I open, good questions. When I open a file for input, it's going to go on the top of the file, and it's going to read the first and the second in this case. Good questions. And the output, exactly the same thing. We're going to open it, output file. Usually what happens is it's going to create this file. So even if it does exist, it's going to delete it and it's going to create a new one. So it's going to be fresh. So now we're going to write these things inside of this. So typically I used to have what? Cout, and I would have these things. So I took the word cout out and I put this one instead of that one. So the names that we are using, a typical one for Microsoft is what? .dat for data, or .txt for text. Anything that is, the files that we are saving here are text right now. We are using it as a text. It is not a binary. We can use the binary files, but right now we are using for the text file right now. After we finish with what we're doing, we got to close the files. So some of these stuff that we have to do here, Java has been taking care of it. So some of these things, so if I don't close the file, it's going to stay open. So this is a typical one. So all I have to do is just put this pound include over here. I have the IF and OF stream defined. I can call it anything I want here. And I open my files. So technically this can be a copy and paste to all the programs I'm doing for chapter 6. As far as, I have the correct names. So that's the standard for all of them. We're going to have a pound include. We're going to define our input and output if we don't have both of them, then we don't need to do that. And then we're going to open it. Okay? From there on, all I'm doing is I'm going to change my CIN to in stream, COut to my out stream. That's all I'm doing right here. So any CIN is going to be changed to this one, any COut is going to be changed to that one. That means I'm going to read from this, I'm going to write to this. Yes, sir. Say what again? Yeah, whatever is in your file, that's fine. Those are text files. Remember, your C++ file is a text file also. In your file, you can have anything you want. You can read one character, you can read one variable, you can read one number, whatever you want to read. Yes?
So you said integer the first, second, and
Uh-huh.
So when I use my in stream, you're gonna looking for the numbers, right?
Okay, right, that's correct. That's correct. So
when you saw some character, you're gonna jump.
it's not going to jump. It's going to just, okay, remember, these are the string. Remember when you had the string in your keyboard, if you were asking for an enter a number and somebody would have been putting their character, what would it do? It wouldn't do anything. It would just sit over there waiting for the number. It doesn't go over it. Yeah, it just does. You don't have number. Does it crash or it just stays there? So when it's expecting, if you push enter, then we're going to have a problem. So it's expecting a number. So we will learn about how to handle some of those things, not the whole bunch of it, but some of it. So here I have this file. Once again, is in the same directory as my executable file that has 1, 2, 3, 4 numbers in it. I'm going to be reading number first is going to read this one. Second is going to read the next one. Third is going to be reading this one. Then I'm going to do what? I'm going to add them together, 1 plus 2 plus 3, and then I'm going to print this one to this file. I'm going to print next line, and remember the carriage return is the same as I had in cout, and I'm going to add them, and I put it right here.
If the in file is A, 1, 2, 3, it's gonna be.
Well, you're going to have a problem. No. We're going to handle those things. But right now, we are going to be just working with that like that. Yeah, we have to figure out a way that, for example, we're going to read everything as a character, and then we're going to change the character to number. Or we're going to definitely remember, these files usually coming from another output of another program. So usually those are being checked already. So having randomly another character in it most likely is not going to happen. And if it does happen, that's a bad thing, so my program is going to crash anyway. So that's, well, we learn about those things. I don't think it's the time right now. Right now, I want to concentrate on the input-output. We will learn some of those things later on. No, it would just basically have a problem with it. Yes, Danza? Okay, so remember, I am looking for this file, infile.dat, right? That is going to be in the same directory. If I want to use different directory, I can put the whole directory right here. But remember, the backslash has a meaning in C++. So backslash, I cannot just put C:\\, because that is a special character. So I have to put two of them. So I can say C:\\, document or something like that. Or I can put my flash drive. Let's say E:\, //. So // means one slash. If I want to put it that way, I can do it. I can redirect it to another place that the file is. But right now, for this, I'm using this current directory for in file and out file. Any other questions? Yes?
You want to change the numbers in the current directory. I don't want to have 5, 10, and 30. How do you do that?
Okay, that's a text file. You can open it as with a notepad and change it. Or you can open it and write it like here. See this OF stream? I can change this in file to put it right here. I open it to the output, and then I just write some stuff to it. I can open any file I want, right? Right now I'm opening the out file for writing. I can open the in file for writing and change the content. So I can technically open it up, write something to it, close it, and open it again and read it. That's not a practical thing to do, but we can do it. Yes?
What if I want to enter the numbers, but output the numbers in a file?
You just read it right here. That's what we did. We output this number right here. We just put it like that, like a cout. You just do a out the stream, and then you put anything you want right here. Just like a cout that you do on a screen, you use this one, and you put it right there. So if I want to put a number 6, that's what I did over here. So this is going to calculate on the 6, right? So I put the 6 over here, and that's the way it's going to print to this file. Hold on.
I mean, can I use cin instead of using in file?
Yes.
I leave the out file there.
Yes, we can mix it up, and that's nothing wrong. We can read from the keyboard and write it to a file, or read from a file and display it on the screen, or at the same time to do both of them in the mix it up. Yes, you can do that. Yes, Kurt? Of course. Okay, yeah, you, and you. Go, Danza.
So is this infile that's going to be regular text file on a desktop? Or we can
Yes.
open it up and just call it infile.dat?
Yes. That's the one you create or you have it. I think I have some of them. I'm going to post it for you guys. Yes.
So the name is must be created in the because like you can have a out file dot dat at the desktop, and you also have an edit desk piece.
Okay. So the name of the file is going to match with the file that you save it on the computer. This program doesn't care. As far as you have that file in the directory, that it can go pick it up. It's like, right,
Must be unique.
on that directory, I mean, how can you have two files with the same name in the same directory? You cannot have that.
Like in the desk C and the desk D, I have
Then you got to use the C colon and D colon. This is the current directory. This is not going to any other disk, any other places. This is the current directory where my executable is. Yeah, if you're going somewhere else, you have to point it where it is going to. That file has to exist in that directory that you're going to point to. Yes, sir.
there's already some stuff in the out file.
That's going to be deleted in this case, and we go over that. In this case, when I don't say anything about it right here, what's going to happen, if I open this one again, everything's going to be deleted. It's not going to cover anything. It's going to delete everything. So every time we're going to write, it's going to write clean. And I show you how not to do that. Yes?
So I call that a
Yes, you can call it George.txt. I don't know. What do you want to call it? I don't know where you got Bobby. I got George. I don't know. Yeah, those are your files. You can call it anything you want. As far as it does exist in your directory, don't care what you want to call it. The name of it, this name right here doesn't matter. This name that here, these ones that we put here doesn't matter. You can call it anything you want. These are just like a variable. The only thing that is reserved is these two right here. Any of these you can change it. Any of these you can change it. And you have to close the file. And you have to close the files. When you're done, you have to close the files. It's like you're working on a Microsoft Word, and if you don't close it, then it's going to just be hanging in there. So you got to close it. So when we talk about the function, the objects, we have some functions related to that. The only thing that we have to keep in mind is if we're using those objects, we're going to be using the dot. Questions? Question?
No.
Okay. So we're using the dot operator to call those functions. And that's where it's talking about over here, that if I create a object from this class, it's going to have all its blueprint. So I can, if I say dot open, it's going to go open in a stream 1 because it's connected to this one. And if I say dot open over here, it's going to go open this one. So I can have multiple of those things. And that's the starting thinking about the class as an object. I'm not worried about them for this class, for this course, but just have some idea how is it working. So in this case, we have the variables, or it's a type IF stream, that's input stream. We are using the dot operator to connect them. Okay, now, sometimes when we try to open a file, we might have an error. The file does not exist, we are looking at the wrong place, and this is a most common mistake that we're going to have in this class. That you try to open a file, but that file is not in the directory that you're looking for. So if my program is looking for a directory and that file is not there, then I'm going to have a problem. So if I don't have my file to read from, can I continue with my program? I cannot do anything if I don't have my data. So most of the time, we're going to exit, we're going to get out of it if it's not. So we're going to exit our program if what we're looking for is not there. So one way of doing it for the open, so I'm just calling it the stuff.dat. So when we do the open, after that we're going to check it to see if it failed. If it failed, we're going to do some messaging and you're going to get out. Okay. In real life, we're going to have some numbers here that later on I can come back and look at it. The cout is going to go to the screen. So we're going to do this for now as a practice, that I'm going to exit the whole program. Exit is a system call that's going to exit the whole program. So in this case, usually what happens, if the file does not exist in the same directory and try to open it up, that's the most common mistake. So once again, we have the pound include on the top. We have the IF and OF defined over here. And then we're going to open it and we're going to check it for error. Once again, this can be like a template. Can be repeated the same over and over. Yes, sir.
So that dot cell is belongs to include CSV.
That is the standard lib, yes.
This belongs to the include.
Uh-huh.
And what you're doing here now is kind of like your driver, and just checking.
We're checking to see if we open the file, we were successful opening it or not.
It's kind of like a driver. Right?
Like,
Like the driver will check driver stuff, so you can check to see if it works.
right. No, it's not like a driver, no. It's just checking to be sure the file that we said open, it opened up okay or not. So we are opening two files, one for the output, one for the input. We're just checking to be sure those files are open before we start using them. That's all we do. So if that file does not exist in the directory, we're going to get input file opening fail. So one way of looking at it, as we said earlier, that we can just use the cin, cout. So because there is no user, we don't need to say enter a number. We don't need to say enter another number or the number you entered is this. So we're just going to use this cin. We're going to put it in the in file, and that's all we have to do. This one we can put it in another file or somewhere else. So the out file can be replaced over here. So I'm going to be looking at the cout, cin. Do I need this cout? Enter a number. No, I don't need it. The cin is going to be replaced with the in file. The cout, the number you entered is, do I need this on the screen? Or if I want to put it in another file, I'm going to change it to out file. Remember, we can mix it up. Now, if I want to open a file and I want to write at the end of it, I don't want to destroy whatever data I had, I'm going to put app at the end of here. App is for append, meaning that I'm going to write, but I don't want to write on the top. I don't want to delete the previous data. I want to keep the previous data. Oh, did I go too fast?
Yeah.
The only thing over here is this app over here. Yes? The iOS. That's why we're using those namespace so we don't have to put these things for C in, C out. So we're going to be using this fout.open, and then we're going to put iOS ::app. This is going to open the file, but it's not going to write on the top of it. It's going to go right at the bottom of it. So if I had this file and I open it like this, I'm going to start writing right here. If I didn't have this, it would write on top of these things. Yes? Yes, sir? Okay. It has this file, a screen output. So if I want to be looking at some stuff for my checking of the program, I can have some couts over here, right, and throughout the program. In real life, when I have my program running in the middle of the night, I'm going to take all the couts out as much as possible, because there's nobody out there on the computer to look at the messages. Or maybe some students. Now, one more thing over here is the file name is going to be as an array of character. We're going to be looking at arrays in the next chapter. So this is just going to be defining as a character. That's the way the name of the file is going to be defined. So this means that it can take from 1 to 16 character in here. So if I want to ask the name of the file from the user, I don't know which file I want to open. I want to ask for the name of the file. This is the way we're going to do it. We're going to define it as a char file name 16, and then we're going to ask for the user to enter it on the keyboard. Remember, cout, cin is a standard. I'm going to read the name that's been displayed on the screen. I'm going to take it from the keyboard, and I'm going to save it. Now I have my file name. I can use it to open it up. And then I'm going to be using the fail to be sure that it opened up okay. Yes, sir? Up to 16. So if you put 17, it's going to cut it to 16. Up to 16. It doesn't have to be 16. It can be up to 16.
What if you enter character and
Number can be treated as a character.
So if I enter A1,
Yeah, it's going to take that one as A1. It's going to take that A1, and it's going to go look for a file name called A1. So here we're looking for the in file name and out file name. So we are asking for the user to put the in file and out file name. We're going to use those names to open the file, and we're going to check to see if it's failing. Once again, these can be used as a template. So we're going to have some kind of introduction. We're going to ask for the input file. This is what the user is going to put, numbers.dat. We're going to use this one to open that file, which is going to contain this stuff. Then we're going to ask for putting the output file. They're going to say sum.dat. We're going to create a file called sum.dat. We're going to read from this, we're going to do our stuff, and we're going to write to this file. And we're going to close it. Is it too much? That's all chapter 6 is about. That was 6.1. So we have a few more sections to go, but that was the meat of chapter 6. So you have 2 weeks to get this one done correctly. Your first assignment is due, is it Monday or Tuesday? They have one assignment for this chapter. Oh, okay. If it's not posted, I'm going to do it right now. So you technically should be done by chapter 5 today. You're going to have 2 more assignments on chapter 5, 1 assignment of this one. If we cannot finish it by Tuesday, then we're going to figure out something. Questions? Remember, I'm going to be using this for the next test. So these things that's coming at the end, you should be able to answer it. And all of these things going to be recorded in the integrity in the Blackboard. So that means the next test, everybody should get 100%. I'm giving you the questions. All right? You good? Yes, sir.
On 6.1, did you mention how to find a specific location?
Right now we are working with the current directory.
So you're not talking about a specific location yet?
You can define any thing in the specific. That's what I said. You can put the whole directory name. It's not going to go look for it. Whatever you tell it is going to go there. So if you have it in the C, you put it C : // my document / project / that. Then it's going to start looking at the current directory where your executable file is. Every project you create, they're going to have a executable file. You're going to create 3 things. You're going to create object file, you're going to create a binary file, and you're going to create an executable file. So that executable file, that directory is going to be looking for those files. Wherever you're going to run it. You can copy that one and run it somewhere else. Remember, the executable file can be run anywhere you want. But your file's input and output is going to be in the same directory that you have your executable file. Any other questions?